I'm Andrew Schneider with Ascent Filtration Testing. Today we're going to be testing these liquid filters in our 3-video series. The first video will be a bubble point / integrity test, the second will be a pressure versus flow, and the third's going to be an efficiency capacity test. That's the big boy everybody wants to see, and I'm looking forward to seeing it just as much as you guys are. We are a third-party testing lab. I'm currently not working with any of these manufacturers. So let's get to it. Today we're going to be running 5 bubble point tests on these oil filters. Royal Purple, Fram Ultra Synthetic, Pure Later Boss, Wix XP, and AC Delco Ultra Guard Gold. All these filters fit a 2019 Chevy Silverado 6.2 liter. The test spec we're going to be using is an SAE ARP901B. One of the fluids in this specification is isopropyl alcohol, 99% concentration, which I purchased from Brighton Laboratories. We'll be submerging the filter elements in this bath of isopropyl alcohol. The temperature spec is 21 degrees to 27 degrees Celsius. I'm going to be using 21 degrees approximately. This is a NIST traceable temperature sensor, so if we want to take a look at any calibrations, we can do that. So let's cut these filter cans open and take a closer look. Okay, I've cut all the filters open. All the components are laid out on the table. From left to right, we've got the Royal Purple, Fram Ultra Synthetic, Pure Later Boss, Wix XP, and AC Delco Ultra Guard Gold. The first component is the end caps we'll look at. See, they all have a different number of holes and different diameter of inlet holes. The cans or housings. Anti-drain back valves, I believe all of these are silicone. The AC Delco here on the far right might be nitrile rubber, I'm not sure. Here are the bypass valves and springs that hold the filter in place. And the filter elements, which we will be testing for the bubble point. The Pure Later Boss and the Wix XP both have internal bypass valves, so that's why you don't see them with the others. So let's get a side profile view so we can take a look at how closely spaced the pleats are together. And let's get a closer look at where the media pleats meet up and they're bonded together. Here's the Royal Purple. The media can be bonded in many different ways. It can have stitching, adhesive, thermoset ultrasonic bonding, and metal crimping, or any combination of. Here's the Fram. It has metal crimping. And perhaps, there could be perhaps adhesive underneath that. It's hard to tell unless you break them open, which I'm not going to do here today. Here's the Pure Later Boss, metal crimping. Pleats are nicely spaced together, but the depth could be a factor. Now here's the Wix XP. You can see that the pleats are spaced much further apart on the Wix XP, but perhaps the depth changes the surface area. So 6 of one, half dozen of the other. Here's the AC Delco. Take special note of this. This looks really tight and really nice, but it's not always how it looks. It's all about performance, and it's hard to say. Okay, here's an example of us running filtered air through the Royal Purple filter element. We plug the one side of the element to make sure the air has no place to go except through the media. We want to reduce that pressure until we see a single line of bubbles coming from the media. Then we record the height of the surface of the fluid to the media, as well as that pressure reading on manometer. I use a well type, but you can also use a digital type with data logging, which I do, but in our case here, it's not necessary. It's more a pass or fail test. Now, depending on the media, we can also calculate the largest pore size. Okay, so we're going to get started with the Royal Purple. I'm applying some pressurized filtered air through the media. You can see the bubbles. Now I filter the air because I don't want to send any solid particulates through the media, blowing a hole in it, and getting a false reading on the bubble point. I spin the media to look for its weakest point, and we want to dial it down and record the pressure with a well-tight manometer when we get a single line of bubbles, and that's why hence the name bubble point. It's also called integrity test. You're looking for holes. You can imagine if you just put a very small amount of pressure and you're already seeing bubbles coming through, and it's not challenging the air at all, the media is not challenging the air, then you would have a problem, an integrity problem. So it's also called an integrity test. Also a largest pore as well, because you can back calculate the largest pore size given this measurement of bubble point pressure, as well as the fluid height of the isopropyl alcohol above that first bubble point. And then you'll need the surface tension and density of the fluid as well. And you can get that through direct measurement or a chart if you know the temperature and properties of the fluid you're working with. So they have machines that'll run these bubble points, but I like this clear aquarium method because you can see what's going on. Some would say it's more accurate, if you're using a machine, but they're just data logging differential pressure versus time, which I can do that. I have differential pressure gauges I can hook up and data log it. But in our case, it's not necessary. This is more like a pass or fail test on these. So we can see 3.8 inches of water column for the Royal Purple at our first bubble point. Sorry for wish I had another camera here for you. I could have did a picture-in-picture with that manometer. Okay, 21.21 degrees Celsius, we're good. We're going to pretty much maintain that for all the filters. So here we go with the Fram Synthetic, Ultra Synthetic. Let's see, we have a plug on the end of that to seal it. There's also reverse bubble points. People come up with all kinds of creative ways to get a bubble point. But here we're using the SAE Aerospace ARP 901B test standard. ISO has other standards. I'm sure ASTM does as well, and probably a few other test organizations. But ultimately, they're trying to accomplish the same thing. And there's different types of filters. This type of test is great for these cartridge filters. So I have my mark where I try to hold it at about a half inch. The bubble point a half inch below the surface of the fluid. There it is. It's the left there. Kind of looks like a tornado vortex. So we run these tests prior to running an efficiency capacity test, because you don't want to waste all that time running a test on a filter that has a hole blown through it. That's not a good filter. You want to make sure it has its integrity. So we got 3.9 inches of water column, and we're within the temp spec for the Fram Ultra Synthetic. Here we go with the Purelator Boss. Now you see this one has a bypass valve in the end cap. so I didn't need to plug that. Yeah, so you can imagine, the expense of running an ISO 4548-12, and you're doing it on a filter that has a hole in it, and you're looking at the numbers on the efficiency, and you're like, oh my god, what's going on here? Like, why didn't we check this prior? And so this test is really a pass-fail indicator prior to running an efficiency capacity test, especially for the non-wovens, because you're not really going to get an accurate measurement if you calculate the largest pore size. So we have 3.5 inches of water column on the Purelator Boss. I'll give you a different angle from the top. Looks like it's pretty near the seam. So here we have a Wix XP. This also has a bypass valve built into the end cap. And oh boy, there we go. Looks like we've got a leak in there on that bypass valve. So, and we can see that single bubble point there. They're teetering right here at a very similar pressure. So what I'm going to do is I'm going to take this thing out, and I'm going to move the spring around and see if there's some kind of debris or something holding up that seal on the bypass valve. Now, to be fair, the other filters had, most of the other filters, 3 out of the 5 of these, are going to have the bypass valves taken off. So we're only testing them for 2 out of these 5 that we're going to be doing here today. So here's a better view. You can see what's happening there. So you can imagine if the fluid were running in the working direction as in its application, it would want to actually push that bypass valve the other direction. So it would be perhaps easier to get through that, I'm not sure. You would want to, the manufacturer would want to take a closer look at what's going on here. We're not going to do that for this experiment. It's kind of outside of the scope of what we're trying to accomplish here. So here's after I've removed the spring, or not removed the spring, but just kind of fiddled with it and pressed it in a few times with my hand. Now you can see the bubble points coming out of the top there, and we're not leaking out of the side of the bypass valve. Okay, so there was a difference in the pressures where that bypass valve started leaking from when I fiddled with it, and I'll post that right now along the bottom of the video. So you can see there was a 0.5 inch of H2O difference in that bypass valve leak from when I fiddled with it. And then we got a 2.7 inch of water for that first bubble point. So here's the AC Delco. Now that seam is what I wanted you to take note on. You can see all the bubbles are coming from that seam. Now it looked really nice, and it still may perform well. It's really hard to say. I would have to run an efficiency test to see if this would affect anything or not. But I don't like seeing it leak like that only at the seam. I feel like if that's sealed, then the media can do its job. Now, to be fair, I don't think this is a non-woven material like the other four that we've looked at, but it's an OEM, so I wanted to test their best for this 2019 6.2 liter Chevy Silverado. So we can see the bubbles. They're all coming from that seam. So we have 1.6 inches of water column, and the bubbles are coming out of the seam. So it's a bit lower than the others. It is what it is. It's a different type of media as well, though. Okay, here's a typical filter testing report I would give to a manufacturer. The test results, we have on the left the filter IDs of all the 5 filters we tested today, the temperature at which all of them were tested, and the measured pressure, which we read from the manometer for each, the immersion depth of each, and that's the fluid above the first bubble point on the filter media. The surface tension and density are found either using tables, which I did, or you can measure those directly as well. The table I got them from was in the aerospace recommended practice 901B bubble point test that we did here today. Standard bubble point pressure and largest pore diameter are calculated using equations contained in the test spec, which I have below. The standard bubble point pressure is just a way to get an apples to apples comparison. They take all bubble point fluids and temperatures, and they correct them with a correction factor to isopropyl alcohol at 77 degrees Fahrenheit. So no matter what temperature you're running or what fluid you're running with, you can compare apples to apples and get that standard bubble point pressure. The largest pore diameter, in our case, this number is not realistic. We used a circular capillary model, assuming a circular pore geometry where the bubbles were coming out of the filter media. In reality, they're not at all a circle. I've seen triangular capillary models and a few other geometric shaped capillary models, but none of them are really accurate. None of them are accurate at all, actually, for the nonwovens. You might be able to come up with some statistical way to do it, and that would be pretty fun to do. But so really, what would happen is this would be a pass or fail instead of largest pore, and the manufacturer would give me a measured pressure point or range, and depending on what we measured for each filter, that filter would either pass or fail its integrity. And if it passed, then it would move on to further testing. I have the equipment used, the equations listed below, and that's about all I can think of. I'm not going to get too deep into these equations. It's a bit outside of the scope of what we're trying to do here today with just measuring these bubble point pressures for these 5 filters. Please subscribe to my YouTube channel and tune in for our second video in our filter testing series, Pressure versus Flow, where we fabricate our mystery threads on our filter base and plumb it into our custom-built test stand.